My name is Ruizhe, and I'm very glad to present our project, Mechanistically Understanding AI for Safety Steering. Next slide, please. Yeah, so as we know, and currently the large language models such as ChatGPT, Llama 3, Llama 2, they need extensive computing resources to train and fine-tune to ensure the safe responses. But we actually don't know how LMs refuse those harmful queries and how we could steer the LM safety mechanism internally across the different languages. So based on these motivations, and we like to ask the three research questions. So the first is which residual stream layer of IR23 is responsible for the safety mechanism? And the second is, can we steer IS23 models activations for refusal across the different languages? And the third is, what kind of geometric properties does the multilingual harmful content have in the activation space? Next, please. Yeah, so here is the basic framework how we steer IR23. So here we use the paired bilingual prompts as an example to demonstrate this. So first, we will feed the harmful prompts in English and French into the IR23, and then we could extract the corresponding activation representations from each residual stream layer. And then here we mainly focus on the final token representation. So we could make the difference between the both languages at the final token representation, and then we got this difference representation. And then we could feed the new prompt, for example, in English, and then we could add this different representation to all tokens at the specific residual stream layer to change the activation space from the English to the French. Next slide, please. Yeah, so based on our this build framework, and we first conduct the experiments on the paired monolingual prompts. So for the harmful prompts, they are from the IR red teaming datasets, and for the harmless prompts, and we actually use the general question answering dataset. And based on this figure, and we can find the IR23 actually is robust regarding the multilingual harmful prompts before the intervention. However, the refusal and safety score dramatically drops when we erase the refusal direction from the harmful activation representation. And the second experiment we conduct is we try to investigate whether we could steer the IR23 by using the language difference direction vector to transfer the input prompts from one language activation space to another one. So here we use the IR red teaming dataset to test and use the cosine similarity to compare the semantic content before and after the intervention. So we can find based on this experiment and the Indo-European language family, especially for the Italic and Germanic subgrouping, actually achieved a higher similarity compared to the other subgrouping language family. And next slide, please. Yeah, and the final experiment we conduct is we try to explore the geometric structure of the different harmful topics in the projected 3D activation space under the multilingual setting. And here we visualize the English activation space, and we can find, so we here show the 4 harmful topics from IR red teaming datasets in English, and we can find the hate speech, bullying, and discrimination are close to each other compared to the profanity topic. And based on this, we can find, because there were some overlaps between these previous 3 topics when we investigate the datasets, and it also means that it will be much harder to steer those similar topics in the activation space compared to the more distinguished harmful contents. Next slide, please. Yeah, and for our future work, and we plan to apply our methodology to more LMs, such as IR23 35 billion model and Llama 2, Llama 2, and Llama 3. And we also try to analyze the different components inside of LM, such as the attention heads and LMP layers, and we try to build the full circuit and understand each LM. And finally, we are currently drafting a workshop paper by summarizing all findings. So if you have further questions, and feel free to contact us. Thank you very much.